This week we're going to work on making more complex figures using Excel. For our exercise, we've got an updated data set uploaded to our Canvas page, which has a number of derived variables in it. This is the same data that we've been working with, but it has a few things to help us move along here. Most notably, the data set includes the density and basal area calculations that you made next week. There are also a number of other variables that are specifically the focus this week, such as understory cover, herbaceous cover, shrub cover, and tree cover. And these are all different stratas of the forests that we have been, the forest data that we've been working with. All right, so more complex figures. What we're doing here is we're going to try to summarize a lot of information about the covers, the various strata covers of these stands in a single figure. So last time we were focused on summarizing specific metrics of stand structure, and now we want to put together a figure that has these things side by side. The reason for that will become clear when we do some linear hypotheses next week. All right, so here's what I've done. I've made a series of figures here that are, or I've made a series of pivot tables, excuse me, that summarize each of these cover classes. Now, the best way to make pivot tables in this case is to go through individual class by individual, or individual strata by individual strata. So I've got a pivot table here for shrubs, and I've got one for trees. Here's a little bit of information about it. I've got the group, that's the plot number, and then the forest type, which I've also updated so that they're streamlined. And I've got the group or the plot in the columns, and then the forest type in the rows. And that makes it very easy for me to summarize this quickly. Also note that I have changed the values here so that I have the average of each cover class. That is very important. Oftentimes, Excel will default to sum or count or something like that, and if you don't fix it, it'll really mess you up. All right, so I've done this for two examples, and of course, you would need to go through and do this for all 4 cover classes. And what I've got here is just like last time, I've got the average for each forest type, and then I've got its standard deviation here. Now, what I've done down here is create a figure. It actually has an error in it, and I'll fix that now. I've got the figure here, and what you can do is once you have your appropriate calculations here, what I like to do is take them and I copy them and then paste values. I recommend that you do that every time. I'm going to delete this because these are actually in a different order. You may see that here it's in let's see, it's in alphabetical order, and here it's not, and there's a reason for that. I'm actually going to go back and I'm going to put this into alphabetical order using the sort function. Let's see here. This is under data and then under sort. And this is the sort dialog. It's something that's pretty helpful. You need to be careful with it. My data has header rows. This is a really important feature, or really helpful feature, and one that you need to pay attention to whenever you sort your data. And I'm going to sort this by site here. Okay, so what that did was it put my measures of the mean, the average cover class here for shrubs and trees, these are the 2 that I've calculated, into the same order as my standard deviations, which are down here. And remember, I've copied these as text, not as equations. And if you copy your equations, which are up here, of course, you're going to run into problems. So what I'm going to do here is I'm going to copy the site IDs, and the reason I'm going to do that is because I want to sort all this data, and I want to sort this data according to the from least to greatest cover class of trees, cover of trees. So I want to sort these sites according to tree cover. And I do that here just by going back up to the sort dialog and selecting trees, and you can see that it has now sorted the sites according to trees. So I've got this pinyon pine stand that's a Walker Pass. It's got about 17% cover of trees versus this old growth Sequoia Grove, which had 35% cover. Now, however, the problem here is that I've sorted the mean cover class, but I haven't sorted the standard deviation. So the error bars, which I added when I made this figure, don't make sense. In order to have them make sense, I also need to sort this. So I'm going to go back here. I've got my header rows. Well, actually, what I need to do is unclick header rows because here I don't actually have header rows. I have removed them. And what this is going to do now is it's going to name the columns. I'm going to sort by the last column because that's what I did up here. And critically, I've got the data that I want to sort highlighted. I'm not going to sort everything up that's above it. I would totally screw up my data set. So I hit OK here, and then that sorts the standard deviations according to where they should be. So for example, let's just make sure here. Oh, this didn't work. This did not work. And the reason it didn't work is because it's sorted according to the standard deviation here. So it's got the smallest standard deviation on top and then the largest one on the bottom. But you'll note that the Sequoia Grove, which has the highest cover of trees, does not necessarily have the highest standard deviation. So I have to come up with a solution to do this. And what I'm going to do is I'm going to create a little column here. I'm going to call it order. 1, 2, 3, 4, 5, 6, and 7. All right. I'm going to go back and I am going to sort my data again according to, oh, here I've got my header rows. I'm going to sort it according to site. And then I'm going to go down here and sort this data according to site. And remember, I need to get the header rows off here, otherwise I'm going to cause myself a lot of problems. And here it's column in. All right, I've done that. Now I can take the order and I can copy it down here. So now Eucalyptus Plantation is number 6, Pinyon Pine is number 1, so on and so forth. And what I can do here, this is the order of tree cover. And what I'm going to do here is I'm just going to sort by order. I do that. They are now in the right order according to tree cover. And what I can do is go down here and finally I can sort my standard deviations in the correct order as well. All right, and there it is. Now I've got everything in increasing order of tree cover, and I've got the appropriate standard deviations matched up with that. And again, what you can see here is that the standard deviation is not necessarily the largest standard deviation is not necessarily tied to the largest mean. Instead, this Fremont Cottonwood Grove has more variation, higher variation than the mean, whereas the Sequoia Grove has the highest tree cover, but it doesn't necessarily have the highest standard deviation.